When Germany launched Operation Barbarossa in June 1941, its armored forces were considered the most advanced in the world. Blitzkrieg tactics, supported by fast and coordinated tank divisions, had already crushed Poland and France. Yet within months, German commanders encountered a weapon that would fundamentally challenge their battlefield superiority: the Soviet T-34 medium tank. Few machines in military history have had such a profound operational and psychological impact on a war. The origins of the T-34 can be traced back to the late 1930s, when Soviet military planners recognized that their existing light tanks were too lightly armored and vulnerable to modern anti-tank weapons. The Soviet Design Bureau at the Kharkiv Locomotive Factory, led by engineer Mikhail Koshkin, was tasked with developing a new tank capable of combining speed, protection, and firepower. The result was the T-34, officially introduced into service in 1940. What made the T-34 revolutionary was not a single feature, but the combination of several advanced design concepts rarely seen together at the time. Its sloped armor significantly increased protection without dramatically increasing weight, allowing it to deflect many enemy shells that would have penetrated vertical armor plates. The tank was powered by a reliable diesel engine, giving it greater operational range and reducing the risk of fire compared to gasoline-powered tanks. Most importantly, it carried a powerful 76.2 millimeters main gun capable of defeating most German tanks encountered during the early years of the war. When German troops first encountered the T-34 in 1941, particularly during battles around Smolensk and later in the approaches to Moscow, they were shocked. Standard German anti-tank guns often struggled to penetrate its armor, and many early German tanks, including the Panzer III and early Panzer IV models, were outmatched in both armor and firepower. German reports from the period described the T-34 as vastly superior to many of their own armored vehicles. This technological shock forced Germany to accelerate the development of heavier tanks such as the Panther and Tiger, which were designed specifically to counter the Soviet machine. One of the most famous engagements involving the T-34 occurred during the Battle of Kursk in 1943, the largest tank battle in history. Thousands of Soviet T-34s played a central role in absorbing the German offensive and then launching massive counterattacks. While the Germans deployed technologically advanced tanks, the Soviets relied on a combination of defensive depth, numerical superiority, and the reliability of the T-34 to wear down the attacking forces. The battle marked a turning point on the Eastern Front, after which Germany increasingly lost the strategic initiative. The success of the T-34 was not based solely on its battlefield performance, but also on its production philosophy. Soviet industry was reorganized to manufacture the tank in enormous quantities, often under extremely difficult wartime conditions. Factories were relocated east of the Ural Mountains to avoid German bombing, and simplified manufacturing processes allowed rapid mass production. By the end of the war, more than 50,000 T-34 tanks had been produced, ensuring that Soviet armored units could replace losses quickly and maintain overwhelming numbers in major offensives. The long-term influence of the T-34 extends far beyond World War II. Its design principles, sloped armor, balanced mobility and firepower, and mass production efficiency became standard features in post-war tank development around the world. Later Soviet tanks, as well as many modern armored vehicle designs, drew inspiration from the engineering concepts first demonstrated by the T-34. Even decades after the war, upgraded variants of the tank remained in service in several countries, and some units were still operational into the late 20th century. Historians and military analysts widely regard the T-34 as one of the most important tanks ever built. Many international defense publications have described it as a war-winning system, not because it was individually unbeatable, but because it combined effectiveness, reliability, and industrial scalability in a way few other weapons achieved. While no single weapon can win a war alone, the T-34 played a crucial role in enabling the Soviet Union to halt and eventually push back the German invasion. In that sense, it did not merely participate in history, it helped reshape it. By 1942, the German army had begun to encounter increasingly powerful Soviet and Allied armored vehicles, particularly the Soviet T-34 and KV-1 tanks, which challenged the effectiveness of earlier German tank designs. German military planners realized that to regain battlefield superiority, they needed a new type of heavy tank capable of destroying enemy armor at long range while remaining highly resistant to incoming fire. The result was one of the most famous tanks in military history, the Tiger I. The development of the Tiger I was initiated in 1941 under the direction of the German Army Weapons Office, Heereswaffenamt. Several companies were involved in the design competition, but the final production version was manufactured primarily by Henschel and Son, with key engineering contributions from German tank designers working closely with the military command. Officially designated Panzerkampfwagen zwei Tiger AUSFE, the tank entered combat service in 1942. What made the Tiger I so formidable was its exceptional combination of heavy armor and a powerful 88mm gun, originally derived from Germany's highly effective anti-aircraft cannon. The gun was capable of destroying most Allied tanks at distances far beyond the effective range of their own weapons. Its thick frontal armor made it extremely difficult for many enemy guns to penetrate, especially during the early period of its deployment. On open battlefields, a well-positioned Tiger could dominate large areas and force opposing armored units to retreat or maneuver cautiously. One of the earliest combat appearances of the Tiger I occurred near Leningrad in late 1942, although initial deployments suffered from mechanical problems due to the tank's complex engineering. Improvements over time increased reliability. By 1943, the Tiger I had become one of the most feared armored vehicles on both the Eastern and Western fronts. Allied tank crews were often instructed to avoid direct confrontation whenever possible, and instead rely on numerical advantage, flanking, maneuvers, artillery support, or air attacks to defeat the heavy German tank. The Tiger I gained legendary status during the Battle of Kursk in 1943, the largest tank battle in history. German heavy tank units equipped with Tigers were used as breakthrough forces intended to smash through Soviet defensive lines. In several engagements, Tiger tanks demonstrated their long-range firepower by destroying multiple enemy vehicles before those vehicles could effectively return fire. However, the battle also highlighted a major limitation. The Tiger was expensive to build, mechanically complex, and difficult to maintain in prolonged operations. While individual tanks could achieve impressive battlefield success, they could not be produced in sufficient numbers to offset Germany's growing industrial disadvantage. On the Western Front, Tiger tanks again appeared during the Normandy campaign in 1944. Several famous engagements involved Tiger units commanded by experienced German tank officers who achieved notable battlefield successes against Allied armored formations. Despite these tactical victories, the strategic situation increasingly worked against Germany. Allied air superiority, artillery firepower, and overwhelming production capacity meant that even the most powerful individual tank could not reverse the broader course of the war, not in total. Only about 1,300 Tiger I tanks were produced, a small number compared to the tens of thousands of tanks manufactured by the Allied powers. Nevertheless, the psychological effect of the Tiger was enormous. Allied soldiers often reported heightened tension when intelligence suggested the presence of Tiger units in the area. The tank became a symbol of German heavy armor strength, and wartime propaganda on both sides contributed to its legendary reputation. From a historical perspective, military historians frequently describe the Tiger I as a classic example of technological excellence that was strategically limited by production realities. International defense historians and publications often praise the tank for its engineering quality, firepower, and battlefield dominance in certain engagements. At the same time, many analysts emphasize that its high cost, logistical demands, and mechanical complexity prevented it from having a decisive strategic impact on the outcome of the war. Despite this limitation, the influence of the Tiger I on post-war armored warfare was significant. Its emphasis on heavy armor protection and long-range firepower influenced future tank design philosophies around the world, particularly in the development of main battle tanks that sought to combine protection, mobility, and powerful armament. Today, surviving Tiger tanks displayed in museums continue to attract global attention, serving as powerful reminders of how technology, industrial capacity, and strategic planning together shape the outcome of modern warfare. In the end, Tiger I did not change the final result of World War II, but it undeniably altered the tactical dynamics of many battles in which it appeared. It remains one of the most iconic armored vehicles ever built, feared by enemies, admired by engineers, and studied by historians as a symbol of both technological brilliance and the limits of military innovation during total war. The appearance of the Soviet T-34 on the Eastern Front in 1941 shocked German military planners and exposed serious weaknesses in existing German tank designs. Tanks such as the Panzer III and early Panzer IV models struggled to penetrate the T-34's sloped armor, while their own armor proved vulnerable to Soviet guns. German commanders quickly concluded that a new tank was needed, one that combined strong armor, high mobility, and powerful long-range firepower. This urgent requirement led to the development of what many historians consider Germany's most balanced armored vehicle of World War II, the Panther tank. The Panther's development began in 1942 under the direction of the German Army Weapons Office, Heereswaffenamt, which initiated a rapid design program to counter the T-34. Several German engineering firms participated in the design process, but the final production model was primarily manufactured by Maschinenfabrik Augsburg-Nürnberg, with components supplied by other industrial partners across Germany. Officially designated Panzerkampfwagen V Panther, the tank entered combat service in 1943. The Panther was designed using lessons learned directly from encounters with Soviet armor. One of its most important features was sloped frontal armor, which increased effective protection while maintaining reasonable weight. Combined with a powerful 75mm high-velocity gun, the Panther was capable of destroying many Allied tanks at long distances while remaining difficult to penetrate from the front. Its wide tracks improved mobility over mud and snow, particularly on the Eastern Front, where harsh terrain often slowed heavier German tanks, such as the Tiger. The Panther's first major combat deployment occurred during the Battle of Kursk in July 1943. Although the tank demonstrated impressive firepower and protection, early production models suffered from mechanical reliability problems, including engine and transmission failures. These issues limited the number of operational Panthers available during the battle and reduced their overall impact. However, as mechanical improvements were introduced in later production batches, the Panther gradually became one of the most effective German tanks of the war. By 1944, Panther units were active on both the Eastern and Western fronts. In defensive battles across Eastern Europe, Panthers proved particularly effective when positioned in long-range firing positions, where their powerful guns and strong frontal armor allowed them to engage enemy tanks at distances were many opposing. Vehicles struggled to respond effectively. On the Western Front, Panthers also participated in major engagements such as the Battle of Normandy and the Battle of the Bulge, where they frequently posed serious challenges to Allied armored forces. In many encounters, Allied tank crews learned that attacking Panthers from the front was extremely difficult, often requiring flanking maneuvers or coordinated artillery and air support to achieve success. Unlike the heavier Tiger tanks, which were expensive and produced in limited numbers, the Panther was intended to serve as Germany's primary medium tank. Approximately 6,000 Panther tanks were built during the war, far more than the number of Tigers allowing Germany to deploy them more widely across multiple fronts. Nevertheless, Germany's industrial capacity was increasingly strained by Allied bombing campaigns and resource shortages, which prevented the production of Panthers in the quantities needed to fully offset Allied numerical superiority. Military. Historians often describe the Panther as one of the most technically effective tank designs of World War II. International defense analysts have frequently noted that it successfully balanced firepower, armor protection, and mobility characteristics that later became defining features of modern main battle tank design philosophy. Many post-war armored vehicles around the world adopted similar concepts, demonstrating the long-term influence of the Panther's engineering approach. Despite its impressive capabilities, the Panther did not change the overall outcome of the war. Germany's strategic situation, fighting on multiple fronts while facing opponents with vastly greater industrial resources, meant that even advanced weapon systems could not compensate for declining manpower and production capacity. However, on the tactical level, Panther units often achieved significant battlefield successes and earned a reputation among Allied soldiers as one of the most dangerous enemy tanks encountered during the conflict. Today, surviving Panther tanks, displayed in museums, continue to attract attention from historians, engineers, and military enthusiasts. They represent both the strengths and limitations of wartime technological innovation. A highly advanced combat vehicle introduced under urgent wartime pressure, capable of exceptional battlefield performance, yet ultimately unable to overcome the broader economic and strategic realities of total war. For many historians, the Panther stands as a powerful example of how technological adaptation in response to battlefield experience can shape the evolution of military design for decades to come. Asterisk, when the United States entered World War II after the attack on Pearl Harbor in December 1941, the country faced an enormous challenge, building a modern armored force capable of fighting on multiple continents. Unlike Germany and the Soviet Union, which already had years of wartime experience, the United States needed a tank that could be produced quickly, transported efficiently across oceans, easily maintained in the field, and operated reliably in a wide variety of combat conditions. The result was the M4 Sherman, one of the most widely used and strategically important tanks of World War II. The Sherman was developed by American engineers working under the U.S. Army Ordnance Department, drawing upon lessons learned from earlier tank models such as the M3 Lee. Production began in 1942, with multiple American industrial companies, including Chrysler, Ford, General Motors, and Fisher Tank Arsenal, participating in one of the largest coordinated military manufacturing efforts in history. This industrial cooperation allowed the United States to produce tanks at an unprecedented scale, ensuring that armored units could be supplied not only to American forces, but also to Allied nations through the Lend-Lease program. Technically, the Sherman was not the most heavily armored or most powerfully armed tank on the battlefield. Early versions were equipped with a 75mm main gun, sufficient against many early war German vehicles, but less effective against heavily armored tanks, such as the Tiger and Panther that appeared later in the conflict. However, The Sherman's design emphasized mechanical reliability, ease of repair, and operational flexibility, which proved crucial in long campaigns where maintenance and logistics often determined battlefield success. The Sherman first saw large-scale combat use in North Africa in 1942, where American and British forces used it against German and Italian armored units. Its reliability in harsh desert conditions demonstrated the value of a tank that could operate consistently under extreme environmental stress. As the war progressed, Shermans became a central element of Allied armored forces in major operations, including the Italian campaign, the Normandy landings, and the advance into Germany in 1944-1945. One of the Sherman's greatest advantages was the sheer number produced. More than 49,000 Sherman tanks were manufactured during the war, making it one of the most produced tanks in history. This massive production capacity meant that Allied commanders could maintain numerical superiority in many battles, quickly replacing losses and sustaining offensive momentum. In many engagements, Shermans operated in coordinated formations supported by artillery, infantry, and air power, allowing them to overcome technically superior enemy tanks through combined arms tactics. During the Normandy campaign in 1944, Sherman units played a crucial role in supporting Allied infantry during the liberation of France. Although German heavy tanks sometimes possessed stronger armor and guns, the Allies compensated through coordinated tactics, improved ammunition, and later Sherman variants equipped with more powerful 76mm guns and specialized modifications, such as mine-clearing devices, flamethrower systems, and amphibious capabilities. These adaptations demonstrated the Sherman's versatility as a battlefield platform capable of fulfilling many different roles. The strategic importance of the Sherman extended beyond combat performance. Because the tank was relatively easy to transport by ship, train, and truck, Allied forces could deploy armored units rapidly across multiple theaters of war. Its mechanical simplicity allowed field crews to perform repairs quickly, ensuring that a high percentage of vehicles remained operational at any given time. In large-scale warfare, such logistical reliability often proved just as decisive as battlefield firepower. Historians frequently emphasize that while individual German tanks, such as the Tiger or Panther, might have been more heavily armed or armored, the Sherman represented a different philosophy of warfare, one based on industrial strength, operational reliability, and coordinated strategy. Many international defense analysts describe the Sherman as a war-winning system, not because it was the strongest tank individually, but because it allowed Allied forces to maintain sustained armored pressure across multiple fronts simultaneously. After World War II, the Sherman continued to serve in many countries for decades, with upgraded variants appearing in conflicts as late as the 1960s and beyond. Its long service life demonstrated the adaptability of its design and the effectiveness of the engineering principles behind it. Today, restored Shermans displayed in museums around the world symbolize the industrial and strategic power that helped shape the Allied victory. In historical analysis, the M4 Sherman stands as a powerful reminder that wars are not always won by the most technologically advanced weapon alone. Instead, success often depends on the ability to combine technology, production capacity, logistics, and battlefield coordination into a unified system. In this sense, the Sherman did not merely participate in the Allied victory, it helped make that victory possible on a global scale. When Germany launched its massive invasion of the Soviet Union in June 1941, the Wehrmacht expected another rapid blitzkrieg victory similar to those achieved in Western Europe. German armored units had previously dominated the battlefield using mobility, coordination, and superior tactical organization. However, During the early stages of Operation Barbarossa, German forces encountered an unexpected obstacle: the Soviet KV-1 heavy tank, a vehicle whose armor proved shockingly resistant to most German anti-tank weapons at the time. The KV-1 was developed in the late 1930s by Soviet engineers at the Kirov plant in Leningrad. Under the direction of the Design Bureau, led by Joseph Cotton, Soviet military planners, having observed the increasing effectiveness of anti-tank artillery during conflicts such as the Spanish Civil War, concluded that future battlefields would require tanks with significantly thicker armor. The KV series tanks were designed to serve as breakthrough, heavy tanks capable of leading assaults against fortified positions while withstanding intense enemy fire. The KV-1 entered production in 1939 and became one of the most heavily armored tanks in the world at the beginning of World War II. What made the KV-1 particularly remarkable in 1941 was its exceptionally thick armor, which in many areas exceeded the penetration capability of standard German anti-tank guns. Early German tanks, such as the Panzer III and Panzer IV, often found it extremely difficult to destroy the KV-1 from the front, and in some early encounters, German crews reported shells simply bouncing off its armor. This created a significant psychological impact on German troops, who were unprepared for an enemy vehicle capable of resisting their most common anti-tank weapons. One of the most famous early engagements involving the KV-1 occurred during the opening months of Operation Barbarossa, when isolated Soviet KV tanks occasionally delayed entire German armored columns. In some documented incidents, a single KV-1 positioned along a key road managed to block advancing German forces for extended periods until heavier artillery or specialized anti-tank weapons could be brought forward. These encounters demonstrated both the strength and the limitations of the KV-1. While it was extremely difficult to destroy, it was also relatively slow and mechanically demanding, making sustained operational use challenging in fast-moving campaigns. Despite these limitations, KV-1 tanks played an important defensive role during several critical battles of 1941 and 1942, including defensive operations around Leningrad and Moscow. Their heavy armor allowed Soviet forces to absorb enemy attacks and buy valuable time, while the Soviet Union reorganized its industrial base and mobilized new armies. Although later German weapons, such as improved anti-tank guns and heavier tanks, eventually reduced the KV-1's battlefield advantage, its early wartime performance contributed to slowing the German advance during some of the most dangerous months of the war for the Soviet Union. The KV-1 was produced in several variants, with attempts made to improve firepower and reliability as the war progressed. However, the tank's heavy weight placed significant strain on its transmission and mechanical components, leading Soviet designers to eventually shift toward more balanced designs such as the T-34 and later heavy tank models like the E series. Even so, the KV-1 remained an important part of Soviet armored forces during the early years of the war, particularly in defensive operations, where its armor protection was most valuable. From a historical perspective, the KV-1 is often viewed as a transitional heavy tank and early demonstration of the battlefield potential of heavily armored vehicles that could withstand intense firepower. Many military historians note that its early encounters with German forces had a lasting influence on German tank development, accelerating programs that eventually produced heavy tanks such as the Tiger. In this sense, the KV-1 indirectly contributed to the escalation of armored warfare technology during the conflict. Today, the KV-1 is remembered as one of the most intimidating armored vehicles of the early World War II period. Surviving examples displayed in military museums continue to attract attention for their massive armor thickness and rugged design. Historians and defense analysts frequently emphasize that while the KV-1 alone did not determine the outcome of the Eastern Front, it played an important role during a critical phase of the war when the Soviet Union was struggling to withstand the initial German invasion. Its ability to delay enemy advances, absorb heavy fire, and challenge German tactical expectations demonstrated how technological surprises on the battlefield can influence operational planning and strategic decision-making. In the broader context of military history, the KV-1 stands as an example of how a single innovative weapon system, even if imperfect, can reshape the dynamics of early wartime encounters and force opponents to adapt quickly. Its legacy lies not only in its battlefield performance, but also in the lessons it provided for future tank design, emphasizing the continuing balance between armor protection, mobility, and mechanical reliability. Among the many armored vehicles fielded by Germany during World War II, few matched the longevity and versatility of the Panzer IV, while later tanks such as the Panther and Tiger often captured public attention due to their heavy armor and powerful guns. The Panzer IV quietly served as the backbone of German armored forces from the beginning of the war in 1939 until its final months in 1945. Its long service life, adaptability, and widespread deployment made it one of the most important German tanks of the entire conflict. The development of the Panzer IV began in the mid-1930s as part of Germany's effort to rebuild its armored forces after the limitations imposed by the Treaty of Versailles. Designed initially as a support tank for infantry operations, the vehicle was intended to carry a short-barreled gun capable of firing high explosive shells against fortified positions and enemy defensive lines. The tank was developed primarily by Krupp, one of Germany's major industrial engineering companies, working under the direction of the German Army Weapons Office, Heereswaffenamt. The Panzer IV entered service in 1937 and soon became an integral component of Germany's early armored divisions. During the early campaigns of World War II, including the invasions of Poland in 1939 and France in 1940, the Panzer IV played a supporting role alongside lighter German tanks such as the Panzer II and Panzer III. At this stage, German armored doctrine relied heavily on speed, coordination, and combined arms tactics rather than the use of heavily armored vehicles. However, the appearance of more powerful enemy tanks, particularly the Soviet T-34 and KV-1 on the Eastern Front in 1941, forced German military planners to reconsider the role of the Panzer IV. Instead of remaining a support vehicle, the tank was progressively upgraded to serve as a primary battle tank. One of the most significant improvements involved replacing the original short-barreled gun with a long-barreled 75mm high-velocity cannon, greatly increasing the tank's anti-armor capabilities. Additional armor plating was also added to improve protection against enemy weapons. These modifications allowed the Panzer IV to remain competitive on the battlefield, even as tank technology rapidly advanced during the war. Unlike many newly designed heavy tanks, which required complex engineering and expensive production processes, the Panzer IV benefited from an established manufacturing system that allowed upgrades to be introduced without halting large-scale production. The Panzer IV saw action on nearly every major front where German forces operated, including North Africa, the Eastern Front, Italy, and Western Europe. In North Africa, Panzer IV units fought British and later American armored forces across vast desert terrain, where mobility and reliability were essential. On the Eastern Front, the upgraded versions of the Panzer IV became one of Germany's primary armored vehicles during major battles, such as Stalingrad and Kursk, where they operated alongside newer tanks like the Panther and Tiger. Although they lacked the heavy armor of those later designs, their reliability and availability ensured that they remained widely deployed One of the defining characteristics of the Panzer IV was its adaptability. The vehicle's chassis served as the basis for numerous specialized variants, including self-propelled artillery, tank destroyers, anti-aircraft vehicles, and engineering support vehicles. This flexibility allowed German armored forces to create a wide range of battlefield capabilities using a common mechanical platform, simplifying maintenance and logistics in the process. In total, more than 8,500 Panzer IV tanks were produced during the war, making it the most widely manufactured German tank of World War II. This large production number reflected both the tank's practical design and Germany's need for a dependable armored vehicle that could be built in significant quantities. Despite increasing industrial pressure from Allied bombing campaigns and resource shortages, military historians frequently describe the Panzer IV as a classic example of a workhorse weapon system, a vehicle that may not have been the most technologically advanced, but proved indispensable due to its reliability, adaptability, and consistent battlefield performance. Many analysts argue that without the Panzer IV, Germany's armored forces would have faced far greater difficulties, maintaining operational effectiveness across multiple fronts simultaneously. Although the Panzer IV did not dramatically alter the final outcome of World War II, its long service life ensured that it played a role in nearly every phase of the conflict. From the rapid early victories of blitzkrieg campaigns to the defensive battles of the later war years, the tank remained a constant presence on the battlefield. Today, surviving Panzer IV vehicles displayed in museums around the world serve as reminders of how sustained production, mechanical reliability, and battlefield adaptability can sometimes prove more strategically valuable than technological superiority alone. In the broader history of armored warfare, the Panzer IV illustrates an important lesson. The most influential military vehicles are not always those with the most powerful weapons, but those capable of evolving alongside the changing demands of war. Through continuous upgrades and widespread deployment, the Panzer IV secured its place as one of the most significant tanks of World War II. By 1943, the Soviet Union had gained valuable battlefield experience in large-scale armored warfare. But it also faced a new challenge: the growing presence of heavily armored German tanks such as the Tiger and Panther. While the widely produced T-34 remained the backbone of Soviet armored forces, Soviet commanders recognized the need for a new generation of heavy breakthrough tanks capable of destroying fortified positions, engaging heavy German armor, and supporting major offensive operations. This requirement led to the development of the IS-2, Iosif Stalin II, heavy tank, one of the most powerful armored vehicles deployed by the Soviet Union during World War II. The IS-2 was developed by Soviet engineers at the Chelyabinsk, Kirov plant, often referred to as Tankograd, the massive industrial complex responsible for producing many of the Soviet Union's armored vehicles during the war. The design evolved from earlier heavy tank concepts such as the KV series, incorporating lessons learned from their operational strengths and weaknesses. The IS-2 entered service in 1944 and quickly became a key component of Soviet heavy tank units assigned to major offensive breakthroughs. One of the most distinctive features of the IS-2 was its 122 mm main gun, one of the largest tank guns mounted on a production tank during the war. This powerful weapon was capable of destroying heavily armored German tanks at combat ranges, and was also extremely effective against fortified defensive positions such as bunkers and urban strongpoints. In addition to its firepower, the IS-2 featured improved sloped armor compared to earlier Soviet heavy tanks, enhancing protection without excessive increases in weight. Although the tank's rate of fire was slower than that of some smaller caliber guns, its destructive impact per shot made it a formidable battlefield weapon. The IS-2 first saw large-scale combat use during Soviet offensives in Eastern Europe. In 1944, where it was employed as part of specialized heavy tank regiments designed to support major breakthrough operations. These units were typically deployed at critical points in the battlefield, advancing alongside infantry and medium tanks to break through heavily defended German positions. The tank's combination of heavy armor and powerful gun allowed it to engage both enemy tanks and defensive fortifications, making it particularly valuable in offensive operations aimed at retaking occupied territories. One of the most significant roles of the IS-2 came during the final campaigns toward Berlin in 1945. In urban combat environments, where enemy forces often relied on fortified buildings and defensive strongpoints, the IS-2's large-caliber gun proved especially effective. Soviet forces used IS-2 units to spearhead assaults against heavily defended German positions, clearing paths for advancing infantry and supporting vehicles. Although urban warfare exposed tanks to close-range anti-tank weapons, the heavy armor of the IS-2 provided an important level of protection in these intense combat situations. In total, approximately 3,800 IS-2 tanks were produced during the war. While this number was smaller than the production figures for medium tanks like the T-34, the IS-2 was never intended to serve as the primary mass-produced tank of the Soviet Union. Instead, it was designed as a specialized heavy assault vehicle, used in decisive breakthrough operations where concentrated firepower and strong armor were essential. When used in coordination with medium tanks, artillery, and infantry, IS-2 units contributed significantly to the success of late war Soviet offensives across Eastern Europe. Military historians often describe the IS-2 as one of the most effective heavy tanks of the later stages of World War II. International defense analysts frequently note that its design represented the Soviet Union's growing experience in balancing firepower, protection, and battlefield practicality. Although it was slower and had a lower rate of fire than some German tanks, its powerful gun and strong armor allowed it to perform its intended role, effectively breaking defensive lines and supporting large-scale offensive operations. The long-term influence of the IS-2 extended into post-war tank development, where many armored vehicle designs continued to emphasize heavy frontal armor and large-caliber main guns. Surviving IS-2 tanks preserved in museums and memorial sites across Europe and Asia remain symbols of the Soviet Union's final offensives that ultimately led to the defeat of Nazi Germany. Historians often point out that while no single tank determined the outcome of the war, vehicles such as the IS-2 played a significant role in enabling the Soviet advance into Central Europe and the eventual capture of Berlin. In the broader context of armored warfare history, the IS-2 stands as an example of how battlefield experience drives rapid technological adaptation. Developed in response to the challenges posed by heavily armored enemy vehicles and fortified defensive systems, the tank demonstrated how concentrated heavy firepower, when used strategically, could help shape the outcome of major military campaigns. Its legacy remains closely tied to the final chapter of the Eastern Front, where the Soviet Union's armored forces pushed steadily westward toward victory. In the early years of World War II, the British Army faced a difficult strategic reality. Rapid German armored advances across Europe demonstrated the effectiveness of fast-moving tank formations. Yet British military planners also recognized the continuing importance of heavily armored vehicles capable of supporting infantry in difficult terrain and fortified battlefields. To meet this need, Britain developed one of the most distinctive tanks of the war, the Churchill infantry tank, a vehicle known for its heavy armor, climbing ability, and remarkable adaptability in specialized combat roles. The Churchill tank was developed in response to the urgent lessons of the 1940 campaign in France, where British forces experienced the devastating impact of German blitzkrieg tactics. British designers sought to create a tank capable of crossing trenches, climbing steep obstacles, and advancing alongside infantry under heavy enemy fire. The design was produced by Vauxhall Motors, working under the direction of the British War Office, and the tank officially entered service in 1941. Named after British Prime Minister Winston Churchill, the vehicle symbolized Britain's determination to resist and eventually reverse the Axis advance. One of the Churchill tank's defining characteristics was its exceptionally thick armor, which provided strong protection against many anti-tank weapons during the early and middle stages of the war. Although the tank was slower than many other armored vehicles, it was designed specifically for infantry support operations, where speed was less important than survivability and the ability to operate in challenging environments. Its long track system allowed it to cross trenches, rubble, and rough terrain that could stop many other tanks, making it particularly valuable in complex battlefield conditions such as mountainous regions or urban combat zones. The Churchill first saw significant combat use during the Dieppe raid in 1942, an Allied amphibious assault against German-occupied France. Although the overall operation encountered serious difficulties, the performance of Churchill tanks demonstrated both their strengths and limitations. Some tanks successfully traversed obstacles and engaged enemy defenses, while others became immobilized on the beach due to terrain challenges. The experience provided valuable lessons that influenced later improvements to the tank and the development of specialized engineering variants. As the war progressed, the Churchill tank became increasingly important in a variety of campaigns, particularly in North Africa, Italy, and Northwest Europe. Its ability to operate effectively in mountainous and heavily fortified terrain made it especially useful during the Italian campaign, where steep landscapes and fortified defensive lines often limited the effectiveness of faster tanks. In these environments, Churchill units supported infantry advances by absorbing enemy fire and providing sustained close-range firepower against defensive positions. One of the most notable advantages of the Churchill tank was its adaptability into specialized variants. Engineers developed numerous versions equipped for unique battlefield roles, including armored bridge layers, mine-clearing vehicles, flamethrower tanks, such as the famous Churchill Crocodile, and engineering support vehicles used for obstacle removal and fortification assault. These specialized vehicles played an important role in Allied operations, particularly during the Normandy landings and subsequent battles in Western Europe, where heavily fortified German defenses required innovative armored engineering solutions. Although the Churchill tank was not designed to be a high-speed tank-versus-tank fighter like some German or Soviet vehicles, its heavy armor and specialized capabilities made it extremely valuable in combined arms operations. British and Allied commanders frequently used Churchill units in situations where terrain, fortifications, or intense defensive fire demanded a vehicle capable of advancing steadily under pressure. In such roles, the tank often performed effectively, earning a reputation among Allied troops as a dependable armored support platform. In total, more than 5,600 Churchill tanks were produced during the war. While not the most numerous Allied tank, its long service life and extensive use in specialized roles ensured that it played a significant part in several major campaigns. Military historians often describe the Churchill as an example of a tank designed for a specific operational doctrine, not necessarily the fastest or most heavily armed, but highly effective when used in the type of combat for which it was intended. Today, preserved Churchill tanks displayed in museums across the United Kingdom and other countries serve as reminders of the diverse approaches to armored warfare taken during World War II. Analysts frequently note that the Churchill demonstrated how specialized engineering capabilities could be just as important as raw firepower in determining battlefield success. by supporting infantry advances, overcoming obstacles, and enabling engineering operations. The Churchill tank contributed to Allied victories in environments where other armored vehicles might have struggled to operate effectively. In the broader history of armored warfare, the Churchill represents an important lesson. Battlefield success does not always depend on speed or firepower alone. Sometimes, the ability to endure heavy fire, traverse difficult terrain, and support coordinated military operations can make a vehicle just as strategically valuable. Through its resilience and versatility, the Churchill tank secured its place as one of the most distinctive and operationally significant armored vehicles of World War II. As World War II progressed, armored warfare evolved into an intense technological contest between increasingly powerful tanks and the weapons designed to destroy them. German military planners, facing growing numbers of Allied armored vehicles on multiple fronts, recognized the need for highly specialized tank destroyers, capable of eliminating enemy armor at long range. One of the most formidable results of this effort was the Jagdpanther, widely regarded as one of the most effective tank destroyers of the entire war. The Jagdpanther was developed in 1943 by German engineers under the direction of the Army Weapons Office, Heereswaffenamt. Instead of designing an entirely new chassis, German planners chose to mount a powerful anti-tank gun onto the highly capable Panther tank chassis, combining mobility, armor protection, and firepower into a single vehicle. Production was carried out primarily by MIAG, Maschinenbau und Bahnbedarf AG, and MNH, Maschinenfabrik Niedersachsen Hanover, and the vehicle officially entered combat service in 1944. The defining feature of the Jagdpanther was its 88mm pack, 43 high-velocity gun, one of the most powerful anti-tank weapons used during the war. This gun had the ability to destroy many Allied tanks at extremely long distances, often before the enemy could effectively respond. Combined with the sloped armor inherited from the Panther design, the Jagdpanther offered both strong protection and exceptional long-range lethality. Unlike turreted tanks, the Jagdpanther used a fixed superstructure, which allowed for a lower profile and heavier frontal armor, though it required the entire vehicle to turn in order to aim outside its limited firing arc. The Jagdpanther first saw major combat during the Normandy campaign in 1944, where German forces attempted to halt the Allied advance following the D-Day landings. In several engagements, Jagdpanther units demonstrated their ability to destroy multiple enemy tanks from concealed positions, using long-range firepower and defensive ambush tactics. Allied armored crews quickly learned to treat the presence of Jagdpanthers as a serious battlefield threat, often requiring coordinated artillery, strikes, or air support to neutralize them. Another notable deployment occurred during the Battle of the Bulge later in 1944, Germany's final large-scale offensive on the Western Front. Jagdpanther units participated in defensive and offensive operations, taking advantage of forested terrain to conduct ambushes against advancing Allied armored columns. In favorable conditions, the combination of powerful weaponry, strong frontal armor, and accurate long-range targeting made the Jagdpanther one of the most dangerous anti-tank vehicles encountered by Allied forces. Despite its impressive battlefield capabilities, the Jagdpanther suffered from the same strategic limitations that affected many advanced German armored vehicles late in the war. Production numbers were relatively low. Approximately 400 units were built due to increasing industrial shortages, Allied bombing campaigns, and the growing difficulty of manufacturing complex armored vehicles under wartime pressure. As a result, the Jagdpanther's tactical effectiveness could not translate into a decisive strategic advantage for Germany. Military historians frequently describe the Jagdpanther as one of the most technically successful tank destroyer designs of World War II. Defense analysts often highlight its balanced combination of mobility, firepower, and armor, noting that few other vehicles of the era could match its long-range anti-tank performance. Many modern armored warfare studies continue to reference the Jagdpanther as an example of how a well-designed tank destroyer could achieve significant battlefield effectiveness when used in defensive or ambush roles. The influence of the Jagdpanther extended into post-war armored doctrine, where the concept of heavily armed tank destroyers shaped the development of specialized anti-tank vehicles in several countries. Although the role of dedicated tank destroyers gradually declined with the emergence of modern main battle tanks capable of fulfilling multiple combat roles, the Jagdpanther remains an important historical example of a vehicle optimized specifically for anti-armor warfare. Today, surviving Jagdpanther vehicles preserved in museums are often regarded as symbols of advanced wartime engineering. Historians frequently emphasize that while the Jagdpanther did not change the overall outcome of the war, it demonstrated how technological innovation could temporarily shift tactical advantages on the battlefield. In several engagements, small numbers of these vehicles were able to delay or disrupt larger armored formations, illustrating the potential impact of highly specialized weapon systems when deployed effectively. In the broader context of military history, the Jagdpanther represents both the strengths and the limitations of late-war German armored development. A technologically advanced and highly effective combat vehicle introduced at a time when Germany's industrial and strategic situation no longer allowed such innovations to influence the larger course of the war. Even so, its reputation as one of the most formidable tank destroyers ever built has endured, securing its place among the most notable armored vehicles of World War II. By the final years of World War II, Germany was facing mounting pressure on all fronts. Allied forces were advancing from the west, while Soviet armies pushed relentlessly from the east. In response to the increasing strength of Allied armored forces, German military planners sought to develop an even more powerful heavy tank than the already formidable Tiger I. The result was the Tiger II, commonly known as the King Tiger, one of the heaviest and most heavily armed tanks ever deployed. During the war, the Tiger II was developed under the supervision of the German Army Weapons Office, with primary manufacturing carried out by Henschel and Son, the same company responsible for the earlier Tiger I. The design incorporated lessons learned from both the Tiger I and the Panther, combining extremely thick armor with the sloped armor, design that had proven effective in increasing protection without excessive weight increases. Officially designated Panzerkampfwagen V Tiger IUSFB, the tank entered combat service in 1944. One of the most impressive features of the Tiger II was its powerful 88mm KWK-43 long-barreled gun, capable of destroying most Allied tanks at long distances. Combined with extremely thick frontal armor, far stronger than that of many contemporary tanks, the King Tiger could dominate open battlefield engagements when properly positioned. Allied tank crews often found it extremely difficult to penetrate the vehicle from the front, forcing them to rely on flanking attacks, artillery, or airstrikes to neutralize it. The Tiger II first saw significant combat use during the Normandy campaign in 1944, where German forces attempted to halt the Allied advance following the D-Day landings. In several engagements, King Tiger units demonstrated their formidable defensive capabilities, engaging Allied armored formations from long range and inflicting heavy losses. However, the tank's immense size and weight also created operational challenges. Mechanical reliability issues, high fuel consumption, and the difficulty of transporting such a heavy vehicle often limited its operational effectiveness, particularly in fast-moving combat situations. The King Tiger also played a role in the Battle of the Bulge in late 1944, Germany's last major offensive on the Western Front. During the offensive, Tiger II units were used as spearhead forces intended to break through Allied defensive lines. While the tanks proved extremely dangerous in direct engagements, logistical constraints, including fuel shortages and maintenance, difficulties prevented many units from sustaining long-term operations. Some vehicles were abandoned or destroyed by their own crews when mechanical failures or lack of fuel made withdrawal impossible. Approximately 490 Tiger II tanks were produced during the war, a relatively small number compared to the thousands of tanks fielded by the Allied powers. Germany's increasingly strained industrial capacity, combined with heavy Allied bombing campaigns, limited the production of complex heavy tanks such as the King Tiger. As a result, despite its formidable battlefield performance in certain engagements, the Tiger II could not significantly alter the strategic balance of the war. Military historians frequently describe the Tiger II as the pinnacle of German heavy tank engineering during World War II. Defense analysts often highlight its exceptional armor protection and long-range firepower, noting that it represented the culmination of Germany's heavy tank development philosophy. At the same time, historians also emphasize that the tank's complexity, cost, and logistical demands illustrated the limitations of relying on highly sophisticated weapons systems in a total war environment where industrial output and supply lines were decisive factors. Although the Tiger II did not change the outcome of the war, it left a lasting impression on both soldiers and military engineers. Its design influenced post-war discussions about the balance between heavy armor protection and battlefield mobility, contributing to the evolution of armored warfare doctrine in the decades that followed. Surviving Tiger II tanks displayed in museums today continue to draw global attention, symbolizing both the technological ambition and the strategic challenges faced by Germany during the final phase of the conflict. In historical perspective, the King Tiger represents a powerful lesson about the relationship between technology and strategy. A weapon system can be extraordinarily advanced and still fail to achieve decisive results if production capacity, logistics, and strategic timing do not support its deployment in sufficient numbers. The Tiger II's story reflects this reality, a remarkable engineering achievement introduced at a moment when the broader conditions of the war had already turned against the nation that created it. Nevertheless, its reputation as one of the most formidable heavy tanks ever built ensures that it remains a prominent figure in the history of armored warfare. Today, the legendary tanks of World War II T-34, Tiger I, Panther, M4 Sherman, KV-1, Panzer IV, IS-2, Churchill, Jagdpanther, and Tiger II no longer dominate battlefields, yet their presence remains deeply embedded in global historical memory. Many surviving vehicles are now preserved in military museums, national memorials, and historical parks across Europe, Russia, the United States, and other parts of the world. Countries such as Russia, Germany, the United Kingdom, France, Poland, and the United States maintain carefully restored examples that are displayed as symbols of technological history and the sacrifices made during the war. Some of the most famous preserved tanks can be found in institutions such as the Kubinka Tank Museum in Russia, the Bovington Tank Museum in the United Kingdom, the National World War II Museum in the United States, and several open-air military museums across Eastern Europe. These vehicles are often restored to operational condition for historical demonstrations, allowing modern generations to witness the scale, engineering complexity, and physical presence of the machines that once shaped the course of global conflict. However, many thousands of wartime tanks no longer exist. A large number were destroyed in combat, scrapped in the decades following the war, or lost in remote battlefields where recovery was never possible. In some regions of Eastern Europe and North Africa, occasional discoveries of rusted tank remains still occur, serving as quiet reminders of the vast industrial scale of World War II armored warfare. Each surviving vehicle therefore represents not only a technological artifact, but also a rare historical survivor of an era defined by total war. From a historical perspective, the influence of these tanks extended far beyond individual battles. Their development accelerated advances in engineering, metallurgy, manufacturing systems, logistics, and military doctrine, shaping the evolution of armored warfare throughout the second half of the 20th century. Many design principles introduced during the war sloped armor, improved suspension systems, diesel engines, and high-velocity tank guns became foundational elements of modern main battle tanks still used today. More importantly, the existence and large-scale deployment of these armored forces significantly influenced the survival and political fate of entire nations. Armored warfare played a decisive role in determining territorial control across Europe, North Africa, and Asia. Countries that succeeded in maintaining large, reliable armored production systems supported by strong industrial capacity and logistical networks were often able to sustain long campaigns and defend their national existence. In this sense, tanks were not merely battlefield weapons. They became instruments of national survival during one of the most dangerous periods in modern history that international historians and defense analysts generally agree that while no single tank type determined the final outcome of World War II, the collective presence of armored warfare technology profoundly shaped the conflict's strategic direction. Nations that mastered the integration of tank production, combined arms tactics, and industrial logistics gained decisive advantages. The lessons learned from these experiences continue to influence military planning, defense policy, and technological development even in the present day. Today, the tanks that once fought across continents stand silently in museums and memorials, transformed from weapons of war into historical educators. They remind humanity of both the destructive potential of industrialized warfare and the importance of technological innovation, strategic planning, and international cooperation in preserving peace. Their steel hulls no longer move across battlefields, but their historical impact continues to shape the world we live in.